So we're going to finish up with the last types of radicals that we have to deal with, and they don't look like radicals like we saw before where there's like a square root or a cube root. Like this one's the square root, this one's the cube root problem. But fractional exponents are also radicals, and here is why. So if we just take that x to the 3/4 and break down what that means, that is the same thing as taking the 4th root of x and cubing it. Or you can think about it this way, you're taking x cubed inside the 4th root. It doesn't matter which one you do first. So notice the bottom number is the root, and the top number is what you're raising that root by. Now, you don't need to go and convert every single one of these into a radical notation is what it's called. There's actually an easy way of getting rid of it. So first thing I'm going to do, though, before I explain that, is I'm going to go ahead and divide both sides by 2, like normal, because you want to get the radical, in this case, x to the 3/4. We want that on its own. So if x to the 3/4 equals 8. Okay, so then the big question is, how do we get rid of that exponent of 3/4? Well, let's take it piece by piece. So to get rid of the 4th root, so if we were just doing the 4th root of x, you'd get rid of that by raising it to the 4th power, right? And then to get rid of an x cubed, you would get rid of that by cube rooting it, correct? Well, as an exponent, cube rooting is the same thing as putting something over 3. So I don't know if you notice, but if I go ahead and raise it to 4/3, take a note. Both of these are just reciprocals of each other. So you're raising both sides to the reciprocal. Sweet. So by doing the reciprocal, those cancel out. These right here that I highlighted. Wow, that was ugly. Sorry. Those cancel out. And you get x equals 8 to the 4/3, which if you do in a calculator, it'll tell you. If you don't use a calculator, it's okay. I usually take the cube root of 8 and then raise it to the 4th power if I need to. And I usually do this in my head, but you don't have to do that. So cube root of 8 is 2. 2 to the 4th is 16, so that would be your, answer. It's 16. And I don't need you to look for extraneous solutions for these ones, so just square root problems. So let's do another one. There is something special in some of them we have to watch out for, and that is going to be evident on this problem. So once again, the way you get rid of a fractional exponent is you raise both sides, not just one, but both sides, to the reciprocal. That cancels out the fractions. So those are gone. And you're left with x plus 1 equals. Now, if you want to do it in your head, great. So you have the square root of 16 raised to the 3rd power. Square root of 16 is 4. 4 to the 3rd is 64. Okay. Now, there is something we have to watch out for. When you raise both sides to an even power, you have to add in a little plus or minus. Or sorry, I said raise to an even power. When the denominator is an even power. Okay? And I'm going to make a little note of that. Wow, that is the ugliest little line I've ever seen. Let's fix that. So if these are even, so the denominator is even, add a plus or minus to the answer. Okay. So that was really important. From there, we have x plus 1 equals positive 64 and x plus 1 equals negative 64. So I like to break them both up. because one of them is going to give us positive 63 if I subtract 1, and the other one is going to give us negative 65 if I subtract 1 from both sides. Okay, so I usually split them up into 2 different equations. Great, so that's the big thing you need to watch out for. So notice on the previous problem, we did not put a plus or minus in front of our answer, and that's because, and the denominator I'm talking about is when we personally raise it to an exponent. So this exponent was to the 4/3. The denominator is odd, which is why I didn't put a plus or minus in front of my answer.